Let us get started with our last topic. Some more DDL commands, data definition language. How do we create tables? While creating tables, are there any other options that we need to take care of? There is one constraint called check constraint. For example, if you are entering some data, let's say credit limit, minimum credit limit should be 1000. So I want to have a column called credit limit, and I want to check with this condition that I want to put a check, I want to put a constraint that that credit limit column has to be more than 1000. Or if you're talking about age column, if the data set is loans data, you cannot have a customer whose age is less than 18 still taking a loan. That is not possible. If you want to give that constraint, you can give check constraint. Check is one of the additional constraint that you can add when you're working on creation of the tables. Let us see how check command works. Okay, let us create a table. I'm creating a new table. Create table. Let me expand this. Create table. What's that? Create table. Give the table name. What's the table name? Employee. Employee table is already there. Employee 2. That's the new table that I'm giving. Create table employee 2. And what I want to have is employee number. Employee number. Okay. And that employee number, there should be no space in between. Employee number, that should be integer and not null. That's my constraint. That is also a constraint, non-null constraint. Apart from that, I want to have the name of the employee. I should be writing employee name, employee underscore name. That should be a varchar of the size 50. That should be fine. Null values are allowed, no problem. Age must be an integer. Okay. Age must be an integer. Now, usually I stop it here, isn't it? Usually that creates the table. That's not a problem. Usually that creates the table. What's that? Usually that creates the table, but I want to give an additional constraint here. What is my additional constraint? The constraint name is check constraint. What is check constraint? I want to check, okay, if age is 18, then only I want to allow the data. Above 18, only that age is allowed. Like the way not null, employee number, the constraint is not null. Sometimes the constraint is unique, but here the constraint is it can take nulls, it can be unique, it need not be unique always. But the constraint here is minimum value of age is 18, everything should be above 18. If I execute this, then that table will be created. If I refresh this and go to that table, in the tables, what's the table name? Employee 2. If I go there, then if I see the constraints, or where exactly will that appear? Is it appearing? It's not appearing here, minimum value and all that. Yeah, no, there is no clear indication, but it worked. Okay, it will not allow any data set, any data that is having age, any data point having age less than or equal to 18, that is not allowed. Okay, that is the check constraint. There is another constraint, I think we talked about it, that is called default constraint. What is default constraint? If nothing is entered by default, one value can be given. That is known as default constraint. Okay. For example, in our data set, employee name is missing, let us suppose. Okay. So by default, instead of leaving it as missing value or the null value, I can give some default value because I don't want null value. So I can give default. The default value is FAULT. Default value is, let's say employee name is missing, let's say EMP. Okay. That's the default value that I want to give. If somebody's name is missing, I'm giving it as EMP, or default value is NA, not available. If somebody enters it, well and good. By the way, if I re-execute it, it will not work because we have already created the table. Then it's better to use alter table. Otherwise, you have to drop this table. Let me show both the ways. Okay. So the default value is NA. First, let us drop this table. Drop table employees 2. Drop table employee 2. Now that will drop the table. Yes, the table got dropped. Now if I re-execute this, it worked. Default value is NA. I think there is a way to check the default value. This I'm quite sure. Somewhere in the columns, the default value is NA. I think we have already seen that default value already. That is one way to do it. What if I want to give the age default value as something like 20? If somebody doesn't enter age, I want to give the default value as 20. Now, instead of recreating this table, instead of dropping and recreating this table, I can use alter table command. Alter table employees 2. alter table employees 2, employee 2, that is the one, right? Alter that table, and what you need to do is alter employee number, is it? No, not number, employee name. Employee name, set default. Set default, that's the command. And what's the default? NA is the default. That's the one. Alter table employee to alter employee name, set default as NA. By the way, that was already set. Let us take age and set default as 20. I'm setting the default age as 20. Is that working? Let us check. Let's go to employees 2 again. And if you go to columns, default value of age is 20, that we have just now set that. Okay. Now there is something called index in every table. If you see here, you have seen indices. What is an index? Index will help SQL to browse through the table much faster, query the table much faster. Indexes are those small points, or those values, those pointers that will help SQL to work much faster, query much faster, give you the results quickly. You can take any of these columns and set it as index using a command called create index. Okay. Create index. Indexes will really speed up your overall querying process, especially if the data set is large. You will really feel the need of creating indices. So create index, and you can name the index name. Create index, my name is employee ID index. Okay, that is the name of the new index that I am creating. Okay, now on which table, you want to create? I want to create that on employees. Do I have any indices? On employees, I have the primary key. On employees 2, I don't have any indices. So I will write on employees 2 dataset. I'm creating a new index on employees 2 dataset. And what is the index that you want to create? I want to use this employee number as my index. All right. So as of now on employees 2, there are no indexes. If I use this employee number as index, then if I re-execute this, then if I refresh this on employee number, you can see employee ID underscore index. Index. Remember, this index column can contain duplicate values as well, doesn't matter. So basically you're telling SQL to use this column as a reference while you are doing this querying and all that. Okay. You can give this way to create index, or if you want to have the index, the unique values only. Okay. So here employee number can take non-unique values as well, duplicates as well. But if you want to have an index which is taking unique values only, you can write create unique index. What does it do? It creates an index on the table, but in employee number, duplicate values are not allowed. Okay. So if you write create unique index, duplicate values are not allowed here. If you write index, duplicate values are allowed. Usually unique index is better because you don't want to have, this is almost like a primary key by default. These keys and all that are all anyway indices. Okay. If you do not have any primary keys and all that, you create a unique index. I think directly if you write a unique statement as well, unique constraint, automatically it will be stored as index, isn't it? Yeah. Let us see whether that works or not. Let me create employees 3, and then let me write that as integer not null unique. Let me store that as employees 3. If I create this table, then refresh it, now that is employees 3. I didn't give any index. Employee number is index. If you directly give unique, automatically it is considered as index, then automatically SQL will use it for searching in this table quickly and faster. So you can directly give a constraint unique, or you can create it outside as well. But here you can give a name, unique index or any name you can be given. Okay. And there is another function called auto increment. What is auto increment? As and when you add newer and newer rows, automatically a row gets incremented by one row. Let's say if you have serial number 1, 2, 3, 4, 5, 6, 10, until 10 rows you have filled the data. Tomorrow 11th row comes into that. Serial number, automatically you want to increment it by 1. You don't expect the user to send the serial number. After 10 days, the user doesn't know what is the serial number. You want this field of serial number to automatically get incremented. How do you do that? Here is the option. Let's create employee 4. Here I want to create a new column called serial number. Now the serial number, it's an integer, it's not null. That is all fine. Now, even if the user doesn't give it, what you can do is you can say auto increment. You see this auto underscore increment, it's a keyword, auto increment. If you do like this and then execute it, automatically that serial number will be incremented. What is happening here? It is giving me an error. Let us see. What is it? Incorrect table definition. Table can be having only one auto increment column. Must be defined as a primary key. Is that the case? Must be defined as a key. We have to define it as a key. So let us see whether unique will help us there, or we have to define it as a primary key only. Yeah, this is working. So now employee 4 is created. It must be a key. They are saying it must be an index. Okay. So employee 4 is created. Then if I check that, columns, default value, is it anywhere mentioned serial number is automatically incrementing? Serial number is a key. That's all right. But is it auto incrementing index? Yes, it's part of index. Triggers, portions, DDL. Like auto increment, that exact message is not displayed here, but it is under the index anyway because unique is there. Yeah, auto increment. Either you have to do it that way, or you have to create that serial, usually primary key, because it is not null, it is automatically getting incremented. You can also say, if you avoid this unique, let's say, let me create employee 5. If I create that, you in another way you can say primary key, primary, because the message it says is you have to define it as a key. So I can say that as a primary key also. That's also fine. That's not a problem. Check that out. Is that working? Primary key. If I execute that, that is also working. Check that. 5. Either primary key or it has to be unique. That key, it has to be one of the key. Okay. While you are entering any value into this table, you don't really need to give the value of serial number. That's the whole point of auto increment, isn't it? To insert a new record in this table, we don't have to specify the value of auto increment column. And unique value, a particular value will be automatically assigned or updated 1, 2, 3, 4, and so on. It will be automatically incremented automatically. Now let us see how to work with dates. Already we have worked with dates. The date format in SQL is YYYY, This is one format, date time format, and then timestamp, year formats. These formats are available just like any other system, or just like any other programming language. The dates work there. Here also we work similarly. Let's say if you go to orders table, select, select, select star from orders. You know what? If you are working in some other systems, or if you want to specify the database name also, you can specify sales.orders. If you want to be very specific, then you can say select star from sales.orders. Okay, that is also fine. Or simply orders also fine, because anyway we are using the sales database. Select star from sales.orders, where order date is equal to a particular order date. Okay, first let us get this data. 2003-01-06 is what I want to select, where order date equal to 2003-01-06. This will work. Will that work? Yes, it will. Let's check that. Oops, 2003-02. Why did I give 02? It has to be 01, isn't it? There is exactly one row, the first row. Okay. Or if I want to select greater than or less than, that is also fine. 2003-06 or less, June or less. Less than this, if I want to select all those records, that is fine. You can get all of them. Instead of saying 06, if I say 03, everything below, before March. Yep, that is also fine. Or 02. Oh, yes, that is also fine. Okay. That's how you work with dates. I think dates is pretty easy to work in future. You will not face very big issues related to date anyway. Even if you face any issues, you will be able to handle it for sure. There is one more concept here. Finally, if you look at here, views, there are tables, there are stored procedures. Anyway, stored procedures we discussed. So if you look at the database, inside the database, you have tables, you have views, you have stored procedure, you have functions and all that you can see later on. Tables and stored procedures we have seen. Now, what is this views? View is like a virtual table. View is virtual table based on the query that you wrote. You can create a view, you can create a table, or you can create a view. View also contains rows and columns, just like your real table. Okay. But like in a table, you have data from a particular information, or in a table, you have data from a particular set. Let's say payment table will have only payments related data. Orders table will have only orders related data. Or customer table will have only customers related data. In views, you can hold the result of 4-5 tables. If you're joining some of the tables, their result you can hold in view. Okay. Views are very useful if you want to show only limited content to the user. Then you can give access to only these to these view tables. And whenever the underlying data changes, these view tables will also change. View is like a virtual table. It's not a real table. To create a table, you input the data. But to create a view, you just write a query. That result of that query is stored in this view table. So you query several tables, their result will be stored in view table. If the underlying data changes, then that view table changes. Okay. View always, like whenever you change the data in the backend, automatically view will change the data and show it. For example, the data is present in 4 or 5 different tables. Now, when you use a create table option by merging them, when you update these 4 or 5 tables, look at this. When I update this table, when I update this table, the join will not get updated. But what if I create a view? When I update this table, when I update this table, automatically that view table will get updated. It's like a virtual table that is based out of a query that is created. Now, this is a query. Out of this query, I'm going to create a new table, but that is not really the physical table that will be stored in the database. I'm going to create a view. So create view table, whatever is the table name that you want to give, like order date, order March, orders till March. That's the name that I'm giving as select star from sales orders, etc., etc., etc. Execute this. Your output is ready. Okay. Now, if I see views, refresh this, views orders till March. Let's say if you want to do the same thing using create table, you can do that using create table orders till March. If you do this, that will also work. But what's the major difference? Table orders till date already exists. Let's give a different name, March 1. Okay. Ah, now what is the major difference between this table, which is create orders till March 1, and this view table, which is orders till March? The difference is when this underlying data gets updated, sales orders, view automatically will get updated. When this underlying data gets updated, let us suppose sales orders data get updated, there are few more records that are before March, there are few more records that are added. Then this table orders till March 1, that will not get updated unless until you execute this table will never get updated. It's a physical table that is created, it occupies space, whereas this is a virtual table that is created out of a query. When the data get updated automatically, when you have this view table, that will automatically get updated. View is always up to date. The database engine recreates these views every time. Every time we are changing we are modifying the underlying data, the database clearly updates these view tables. It's like a virtual table. This is a physical table in the database. It gets created. This view is a virtual table. Okay. It doesn't really belong to the database. Okay. That is the story of views. Maybe not all of you will be working on views immediately. It's good to know. That's the story of MySQL or SQL. So there is something called MS SQL. There is something called Oracle SQL. Okay. Or here we discussed MySQL. MySQL is open source. We have discussed everything from MySQL point of view. MS SQL, Oracle SQL, some other SQLs also same commands. Even IBM has one SQL. All of them are same commands. The only thing is there are subtle differences, a little bit of code difference, little bit of syntax difference, very, very little difference. But if you are good at any one of them, let's say if you're good at MySQL, then Oracle, like 95% of the commands will be same. Only 5% of the places, little bit changes will be there here and there. You can adopt them easily. Okay. These are some of the basic to intermediate commands in SQL. You will be able to handle a lot of problems, a lot of practical problems that you're going to face when you're working on a project using these commands that we have discussed in this SQL here. Thank you, everyone.